right, herzlich willkommen. Welcome everyone to the Covestro Arena at K2022. Wind energy, wind power is great, isn't it? It's awesome, right? Has great advantages, it's renewable, it's local, but we have to decrease its footprint because we'll see a lot more wind power installations in the future globally. So how can we actually make wind power circular? How can we decrease its environmental footprint with wind blade recycling? So let's talk about how that can work in the future. And we have a wonderful panel here. So please, as we bring them out, give them a huge round of applause. Come on, guys. Come out to the stage and I'll introduce you. All right. So we have Professor Dr. Florian Turk, who is the CEO of Microwave Solution. Then we have Professor Dr. Bernd Meyer from the University of Freiberg and Stephanie Eiden from Covestro and Christian Haessler. He's the head of the circularity agenda at Covestro. So he's really the strategist and tell us all about the circular strategy behind all of this. So I want to start with, really let you guys introduce yourselves because I said we talk about wind blade recycling. So who are you and what do you have to do with wind blade recycling? Florian.
Yeah, so I am leading and I've co-founded a startup. And what we're doing is we're using waves, microwaves, and we are cutting wind turbine blades into the individual chemical building blocks of monomers, polymers, so that you can really build new products out of it. And we're recovering the fibers, which is very important as well, to maintain the full value of the wind turbine blades. The gases, obviously, we use as well. Zero waste, full value. That's the future of recycling.
Wow, that sounds amazing, and we have to talk about that. So let's find out what academia has to do with it.
Yeah, the academia in the past has a linear economy, had a focus on the linear economy. Now Germany came out of the coal and oil chemistry. So then also the chemical industry. And now we see how we can bring the waste back in the circle. We speak about circular carbon economy. And to come further to, let's say, a circular economy in a total. And the windmills is one of our research part. And we are doing research collaboration with Covestro also in this field to bring the materials back into the, let's say, new windmill blades or other chemicals. That is what we are doing with very traditional technologies, very old technologies invented in Germany, for example, gasification or pyrolysis. So we do a lot of, let's say, C1 chemistry and so in this way. It's a very interesting topic.
All right. So Stephanie, what do you have to do with wind blade recycling and what do you do at Covestro?
Yeah, I'm chemist and I'm working in Covestro. I'm globally responsible for pyrolysis topics. So yeah, what we make with microwave pyrolysis or gasification. And I'm mainly focused on the recycling on rigid foam, but the competition is similar to the resin in the wind blades. So we have here a connection and want to transfer the knowledge to the wind blades.
And Christian, we talked before, you're a techie at heart, so you follow the discussion. Yeah. Then again, in your current job, you have to really concern yourself with the strategy of the circular economy.
Yeah, circular economy for Covestro is very much focused on going away from oil, using alternative raw materials like bio-based materials, CO2-based materials, waste-based materials. But to be successful with circular economy, we need a lot of green energy too, as every other industry needs. And the most exciting topic for me about wind energy and wind blades is we absolutely need it as a green energy. But we also need to keep in mind the circular economy. So we cannot set up these large amounts of wind or solar energy without thinking about how to recycle the material for which we use for these technologies afterwards. And it's a challenge, it's a composite material, so it's a super exciting topic for me, how to recycle wind blades. It must be on our strategy roadmap, that's for sure.
Really good. So let's dive right into it. Florian, Christian just said it's a challenge. Obviously, everyone likes wind power. Then again, it's a composite material, like Christian said, difficult to recycle. What was your idea? Tell us what the current practice is and what you are working on.
Yeah, so what is the idea? First of all, you would like to maintain the entire value which is in there, right? Which in mechanical recycling you lose, right? The fibers are cut and you have a mix of powder with all the different materials, hardly any value. Composite wind turbine blades is a good example of a product where there's so much value in there, material value, resource value, the energy value, you would like to maintain it. But what we see at the moment where we are in building the circular value chains, they still need to be defined. So second principle is agility. When we don't know what we need now, how can we have agile technologies which can go with our different needs? And then you would like to have something which is energy efficient, where you get more energy value out than you have to put in, otherwise it's not scalable. And that's why microwaves, which you can make intelligent, which you can make smart, which can react to the material you have, and with precision you can cut the bonds and molecules where you would like to do it. It's a perfect instrument you can use, like a scissor, where you can cut into the different oligomers, polymers, molecules you would like to have, and further convert as well the gases, and you can recover the fibers in a way you can reutilize them with coating, without coating. So that is deep tech in action, and that is helping us to get to a breakthrough.
It's deep tech in action, yet it sounds quite complicated. I mean, what do we need when it comes to technology? Is it more that we need an advance in technology and materials, or is it that we need a whole different approach when it comes to how we actually then construct the wind blades and how we then close the loop and have a full circle?
The question is, when I understand you right, is the materials, the composite material we have now, this, let's say, sustainable approach for the future also, to have glass fiber and carbon fiber enforced epoxy resins. So we think that is the way, and other composition with other polymers. I think that's a really good approach to have that very effective composites. But to make from an old, to reproduce an old wind blade in the same shape, and after a lifespan of 20, 30 years, to a new one, it has to take a lot of effort to separate the materials and to form from this separated things the new one. Our approach is, we say, we have a very clear destruction of the material. We say, take the glass out of the materials, and then the organics, separate it or bring it down to carbon monoxide and hydrogen. And then you have the basic gases, the thin gas, you can produce all things from it. That is our, let's say, our different approach. The loop is bigger. It means it needs more steps to synthesize than the resins and the polymers. But we can use also very spent and dirty materials, and if you some metals in the things and heavy metals, so we can separate it very clearly. So let's say for more destroyed and not so good quality waste materials at the end.
Wait, Stephanie, what is the current practice? I mean, I assume, well, wind blades, when you're done with them, usually they get shredded and then incinerated, or how's it right now?
At the moment, it's mainly in landfill that we see. Yeah, they put it in landfill, and yeah, they lie there. That will be, there are regulations that it is forbidden from 2025. So then we need an additional solution. Yeah, where we work on at the moment, that will be not ready in large scale in this. Yeah, for our technologies, so that's the next step will be that it's used in the cement production to put it in, then the resin, yeah, heat it up the furniture, and then the glass can go to the cement. But that is also very downcycling, and so we have to develop new technologies, and we think that it will be not one technology, depends on the quality of the waste, on the parts of the wind blades, so that we really need different approaches so that we can cover the whole value, or recover the whole value out of the blade.
So currently we still have that linear approach. So make, take, dispose, it's, end of life means it's in a landfill. with Covestro, you know, being in the beginning of a value chain, what can you do strategically to help this industry or help startups like, you know, Florian's to actually then create a circle? Can you circular product plus a business model, make a business model from it?
Yeah, at the end, it has to be a business model. There are a few framework conditions which you have to keep at the end. No? That is having a financial stability, having a business model. It's also not using too much energy. Yeah? You don't want to recycle on the expense of too many CO2 emissions, so you have to combine these two. And of course, we have to make polyurethane recyclable. This is our product in wind blades, and we cannot offer products to the market anymore that are non-recyclable. They need to be able to go into a circle. So we are working on the technologies to make our products recyclable. It starts with mechanical recycling, but you need chemical recycling too. And you need to add the recycling technologies you need. We talk about pyrolysis here, so you have a set of technologies you can apply. We should apply. Yeah, they have to keep the standards of all chemical processes in terms of safety, reliability, that is clear. They should not emit too many CO2 emissions. They have to be green energy driven. And that is what we try to set up. And I think here the challenge is we are partly still in the lab or pilot phase. And at the end, we talk about very large volumes. So scaling up the technologies is a very specific additional challenge when it comes to circular economy.
So what are the challenges right now, Florian? I mean, for companies like you, are they technical? Are they in regulation? Or is it the business model, like Chris said, that you still need to find? I mean, you founded a company, right? So there must be a business model that you think can work.
Absolutely. So key challenges, and by the way, it's a challenge Covestro is helping to master perfectly for a startup, is circularity means you have many different partners and stakeholders, right? Upstream partners, downstream
Grafting
partners. You have to find the different waste streams. Yeah. It's a big ask for a startup to organize all of those big companies and get into them. Business development for startup with large corporations is difficult enough. So someone has to take the lead, has to organize, has to bring the different partners together, organize a dialogue, design, and help to design the different circular value chains. And that's a true opportunity then for startups like ourselves to apply the technology, to demonstrate how it's working, and then to scale and thrive.
It sounds great. It sounds so easy. I mean, when I look at universities, I mean, they're doing a lot of research. So how can the collaboration between the industry, academia, and then maybe young founders that want to get going help with all of this? I mean, do we still need a lot of research that needs to be done there?
Yeah, for sure. Research not in a lab scale, in a applied scale.
Okay.
On a TRL level, I say 7 or so, 7 to 8 already. We can do it at the university because we have plans to use RDF, residue-derived fuels. That is a municipal waste-derived fuels. When we bring it into this sector, the windmill blade shredder, as a residue-derived fuel, then it has just to adapt existing technologies. We operate large-scale facilities, and when we have tested this with a wind blade feedstock, to recycle feedstock, then we can go in the large-scale industry, and then we speak about a few 100,000 tons a year for recycling. So large scale, we speak about large scale. Then we have another problem. We have the delivery, the chain, the value chain. Who is the deliverer? How many spent plates can be stored in a place and can collect it? That is, we have at the beginning of the side. The feedstock side is the most interesting thing. Then when we will start in a big scale, and we have to do it in a larger scale. Not in a pilot scale. The next one is a demonstration, a big demonstration scale.
So what is the challenge for you when it comes to scalability? I mean, yesterday we had some from Ørsted here, and they're the largest wind power company in the world. They have incredible plans when it comes to how they want to scale up their business. So what prevents you from scaling up? What are the current challenges still in place?
I mean, scaling up has two different elements. So technology-wise and how to run larger capacities is very easy when it comes to microwave-based processes, because you just increase the amount of energy which is absorbed. You just have to further increase the amount of energy you have to give into the system. It is the feedstock which is directly absorbing the energy. So that is not particularly difficult. Scaling up manufacturing, when we're talking producing 100 plants, 160 plants, so that is a scale up for hard tech or deep tech startups, which obviously is a massive challenge, right? Because it's very different than understanding, having the expertise in your technology and optimizing it for different applications. Building scale manufacturing, giving performance guarantees, liability management around the world in different applications. That is a true scale-up problem we're facing. When it comes to obviously building large plants, we have to keep them profitable at the same time. So no startup can build an entire plant or demonstration plant just for demonstration purposes. We need the return of investment in it. So we have to apply it with partners in different applications that they can be profitable right from day one. Because otherwise we'll never get investors who are willing to invest in an unproductive, unprofitable.
What are the factors that are important for that? Energy prices? I mean, it sounds like it also needs a lot of energy.
Oh yeah, but we are getting 2 to 10 times more energy out of the materials we're processing than we have to feed in. So energy-wise, it's very fine. What is demonstrating more and more challenge without a network is access to the feedstock, to the waste. So a lot of waste streams are controlled, a lot of waste streams are owned. How to get access to those different waste streams. The permissions on different materials. And some jurisdictions, you need specific permissions for the feedstock you're processing. All the different materials, polymers, oligomers, hydrocarbon products you're producing. Particularly for agile technologies, that can become a barrier. But otherwise.
And you're just talking Germany and the EU for now, right? I mean, when it comes to regulation globally, you know, I can imagine it's very chaotic, right? I mean, waste management alone is very different in different countries.
But for us, I think it's also important the investment costs. We cannot go from the lab. We need pilot plants that are expensive and that are not economic in this case. And demo plant is perhaps economic, but not also on a low value. And for all these new technologies to come to this invest, also the capex cost, that is in some cases a problem. So for example, in Freiberg, they have already a large demo plant, so that's also special for Academica, I would say, that we can run there also first trials. So really to look for us and also for the others to see how we can reduce the capex cost.
But what's in it for Covestro long term? I mean, you're not doing this and partnering with the startups because it's just a fun project for now. You want to profit from it, you know, strategically long term, right? So, what's your motivation?
I think that should be obvious, right? So we will be fully circular, means we are reusing the material we produce. We get it back at the end of their lifetime, not as a waste, but as a raw material again. And I think the challenges that were described here with getting access to the right waste, enough waste, the sorting, the cleaning, I think this is quite common for a lot of value chains we try to close. This is not special for wind blades, I would say. That's a common topic. But I think the great thing here is it will be a topic, it will be a key topic for the whole first European Union because we need green energy and we need to recycle it. So there is, if you want a market, there is a need to solve that. And there's a lot of challenges around it, for sure. We know that from other recycling projects. But the technology piece here is especially important because we know what challenges composite have. It's a special challenge. So the focus on technology and knowing that there will be a market and a need in a whole region, I think that gives us the framework we need to have to work on all these topics and to stay optimistic. Of course, there's a lot of challenges, but this is what we try to solve, and we solve it together again, not one company alone or one.
And it's not a lot of time left. I mean, you said that's 2025.
Yeah.
So in 2 years, we'll be prohibited to actually, put them in landfills. So is this a growing?
And until 25, we have 8,000 wind turbine blades in the US going into landfills.
Oh, wow. Yeah.
3,800 in the EU. So it's building up, and this stockpile is building up.
That's what I was going to ask, because is this a growing area? Because how many wind blades do we have in Germany alone, and then the EU? When we see, how many are going up, what's the average lifetime of a wind blade?
20 years around.
Okay. So, 20 years ago, we installed quite a few wind turbines already, so they're coming. And
Yeah, so it's the first generation of wind turbine blades, which is now starting to hit the waste streams.
Yeah.
so it's the right time for you to actually
time to
start that business. All right,
Right time to speed up.
really good.
One point is what we see now, it's coming up. We have a lot of project developers are talking with us how we can step in with a positive business case for windmill recycling. And one of such, let's say, maybe first step in is to have let's say, a very simple process route. The simplest one is to generate hydrogen from the organics. So, and when you calculate, let's say, a ratio from a windmill plate, 25 tons or so, the biggest, very big ones, and you separate most of the glass out of it by a separation process, what's possible, then you will get nearly 1 ton of hydrogen for that. And the other one is CO2, and both gases can be used, CO2 for enhanced oil recovery or other things, and the hydrogen for the hydrogen economy. So that could be a business case, already now a business case, and we are now strongly developing together with the partners to such a step-in project, have a discussion,
Really
and we do the tests already now for it.
Fascinating. So at this point, I want to open it up to the audience. Do we have any questions from the audience to our esteemed panel? Also, if you're watching us online through various channels, LinkedIn and YouTube and wherever you are, you can now send us a question and we'll see it here if you want to get your question answered. We have a few minutes left. Do we have any questions? No question for now. First one is always, oh yes, we do have a question. Please.
Yeah, we spoke about a very big challenge, right? There's a lot of wind blades out there that's going to come hitting the market, and if we want to go full circular, we need to bring them back. For the two technologies which are being presented here, microwave and gasification, what kind of upskilling potential are we talking about here? What kind of volumes can you take?
Who wants to go first? Florian?
Yeah, so we're taking two different approaches. One approach is modular, so that you can put it on vessels, bring to the wind parks, you can put it on lorries. Each module is a ton per hour. You can line them up as you want. The other one is to go for plant-based installations, which take up to 100,000 ton per year per one line, but where you can add additional lines next to it. So capacity can be built. It's, again, easy to scale up at a microwave level. The limit is what is in microwave generators available at the moment, and the rest is about algorithms, AI, smart deep tech.
All right.
In gasification, we think about bigger units. That is, let's say, the economy of scale in gasification. To produce synthesis gas, you need really large units. And we start, let's say, with a positive business case about 50,000 tons a year and the open end. So that is the question of the delivery chain of the feedstock. But when we think about such recycling, we see also a mix of not just wind blades, also with other composites and other difficult to mechanically recycle plastics and so. So we have also, let's say, wind blades just as a part for the chemical recycling. Yeah.
And as I understand it, I mean, it's not either or, it's both technologies can contribute to this whole effort, and in some cases it might be better to then, use microwaves, in others gasification might be the process,
what you see is certainly both technologies are representing a shift, right? So from medical, it's going down to the molecular level. So both approaching it from different sides, right? So we are going step by step, the individual monomers, oligomers, whatever's of interest,
separate them.
right? Or you put it to the molecular level, and then you filter, separate out what you need. But what is driving both is you get full value out of the different components, and you can bring it back into new products. And so, I think from the different needs, installations, plans, different streams, different models will demonstrate preferable. But the technology shift we are observing at the moment, I think that is an essential one.
Very good. Thank you for that question. Do we have any more questions from the audience at this point? Any deep tech questions?
I like this term too.
Tech is good, huh? Yeah. So what interests me is, yeah, we talked about the technologies, and there is definitely a need. There are business models that we'll see in the future, maybe many more startups. So, what are the concrete next steps that you are taking with microwave solutions? I mean, what's happening right now, and what are you planning for next year? I mean, next 2 years should be exciting.
Yeah, so right now we are running many different samples for different companies, for different material classes. We have finalized 35 positive POCs with different corporate partners already. We are designing the first plants. We have already 12 pilot systems in which we're running those different systems. We're looking at 160 pre-orders at the moment for systems to get out. So we are streamlining our manufacturing at the moment so that we can master it, because that is quite a lot. And we'll then see how we can further standardize and maybe drive it a little bit into open innovation as well. We have built a modular agile system in which we can combine different plasma modules, distillation modules, the selective polymerization. But there might be other innovators out there as well who can interlink with the technology. And I think when we would like to get pace and drive the change in the pace we need to see, we have to innovate in an open way as well as startups so that we can connect with other great entrepreneurs and innovators.
All right, sounds really exciting. And I asked for a technical question, and we got one from LinkedIn. Thank you for that. So the question is, today the blades are made of epoxy resin and not PU. Can your process be applied to both materials, and can you get out monomers, which then can be separated and reused as the building blocks for, well, then the new wind blades?
Yeah, so for our technology, yes, because it's agnostic to the different materials. So we are not only processing composites, but we are in circular car initiatives, circular tire initiatives, different materials important is each molecule absorbs energy differently. That is what we're using and the way we're depositing energy in different ways. And we're cutting the bonds where we would like to see it. So we're fully agnostic to it. We can mix the different materials, we don't mind, or mix with other waste streams as well.
So if Covestro comes up with like this new magic material,
we come up with polyurethane.
You already have polyurethane? Okay, so.
But for example, for the next generation of PUs, right? It's important to.
Well, I know, in 10 years, who knows? Yeah.
I mean, it's a general challenge to recycle composites, no? Whatever fashion. We also have different ones, and that would be a major breakthrough in general.
Yeah, and you need to be agnostic to the feedstock, because otherwise we have this entire sorting problem, right?
Yes.
We're getting wind turbine blades and the waste streams from many different producers, using different resins, using different materials. The generations are changing different materials. So if each time we have to invent new technologies and build new circular value chains, it will just not work.
Yes.
Right?
Same for gasification. We need a robust recycling technology is able to process all the upcoming and the past feedstock.
All right.
For sure.
And another question just came in. Really good, keep them coming. So, in regards to end-of-life decisions for the currently installed wind turbines and their blades, who are the main liable actors? Who wants to tackle that?
Steffi?
So, I mean, who are the liable actors? What happen? I mean, who's responsible then for the wind blades at the end of their life?
I would change the question a little bit, because you have mentioned we are moving into circular carbon economies or carbon economies. I think we have to more and more understand the carbon we have either in waste or the atmosphere as sources of carbon, right? And it's now starting to harvest carbon from very different sources. So let's look at it as a great resource, not only about liability. In a profitable way, it can be harvested and it can be utilized.
But I think from regulation, the wind turbine, the wind turbine park management is responsible for the recycling, not the producer in the moment.
So ideally they should have an interest in making it circular too.
I think it's not on identifying individual companies or players that are now responsible, right? That is a common responsibility. We always know that circular economy always works only if the players along the value chain work together, and only then it can be solved. So I would really say it doesn't matter who is liable now, because we have to solve it together anyway.
Yeah, absolutely.
Yeah, and the wind parks management will not buy anymore some blades which are not recyclable. So then it goes back to us more or less, no, at the end.
I've sometimes asked me, why not, let's say, adapted green dot system for the producer of the blade? So that is already paid. The recycling, or let's say the future recycling, is already in the price.
I mean, do you have the advantage? They are really big, right? So you can find them easily. It's not like it's small electronic parts where you never know which material is it. So bringing them back in a well-organized way, that should be solvable relatively easily.
All right. Do we have any more questions from the audience? Anyone? No.
Yes.
All right. So last question from LinkedIn. We're almost out of time. So when are first TPU blades constructed, and when will they be used? And which lifetime do you expect from TPU blades?
So it's not TPU, it's a special polyurethane resin, and we have already built some blades in China. And yeah, we hope that our blades...
Polyurethane blades.
Yeah, polyurethane.
It's a polyurethane composite. And of course, it's not only the recyclability, also other material properties count as in every application, right? It's on flexibility, it's on lifetime, and of course, there you have to offer an advantage too. Wind blades get always longer and longer. They need to pass all these mechanical tests, right? They should be in operation 20 years. So those are for the material, there are more challenges, of course, than only the recyclability. But the recyclability is a key property from now on too.
So no matter the future material, you guys will find ways to recycle them, close the loop. And I think the secret, as we've talked about so many times already, is in collaborating, coming together, finding joint solutions, talking to each other, finding out what it needs. So keep talking to each other, keep finding these solutions. We're looking forward to hearing more about this whole topic. Thank you for watching, for coming. Thank you for taking the time, sharing your experiences and your insights. And this is your applause.
Yeah.
Thank you.
Thank you.
Thank you.
Thank you.